In this video, I'm going to explain how to multiply binomial with a higher power. So we call that expand the integral power of binomial using binomial theorem or Pascal's triangle. So first of all, what is a binomial? Binomial means you two terms and the power. Any power we should be able to expand without doing repetitive multiplication. So let's explore. What is a plus b to the 0 power? 0 power gives you 1. A plus b to the 1, you get a plus b. A plus b square. So most common misunderstanding students have is a square plus b square, but that is not true. There is always the middle term, which is 2ab. Now, how do we multiply a plus b square with a plus b, which gives us third power? So you should be able to figure out the pattern here is a first power, second power. So my first and last terms are a to the third, b to the third. Then this is the second power, so we have a three terms. This is a third power, so I'm expecting four terms. Now what will be those four terms is if you multiply a times 2ab, so 2a square b, and a square b, so that together is a 3a square b. The middle term will be uh, 3ab square similarly, and the last term is ab to the fourth. So what will be a plus b to the fourth power? We expect that there will be five terms. And you can see that what will be the pattern here. So let's explore the pattern. We can see that 1, 2, 3, 4, 1, 2, 3, sorry, my bad, 4. This is a power of a square. So this would be a to the third, b square. So that will be b to the third. Oh, here it should be b to the third. And this would be a square, b square. So then left the coefficient, and you can explore this further how we got them, but let's cut it short and I give you the answers. And we just have to understand the pattern here. What is the pattern is the first is a 1 1 1 1 1. This last is also 1 1 1 1 1. If it is a 2, then we have a 3 terms. If it is a 3, we have a 4 terms. If it is a 4, we have a 5 terms, and onwards. Next is if we remove all those alphabets A and B, you should be able to see the pattern. 1 2 1, 1 3 3 1, 1 4 6 4 1, 1 5 10 10 5 1. And if you explore this pattern, you should be able to see that this is nothing but Pascal's triangle. So let's take a look at further. What do we see? What is the pattern above? So I can say that the pattern is powers of A are decreasing. You can see that 4, 3, 2, 1, 0. Powers of B are increasing 0, 1, 2, 3, 4. And the first and last coefficients are 1. You can see that. Second coefficient is the same as this power. So this is a pretty mind-blowing pattern here. If this is a 4, so then that's a coefficient is 4. This is a 3, the coefficient is 3. If it is 5, coefficient is 5. So this is not just a coincidence, but this happens that they are nothing but the combination. In a previous section, we learned this. What is a 3 choose 0, which means a combination. Given a 3, you have to choose a 0. So that means this number is there is only one way you can choose nothing. You are given a 3, choose 0. 3 choose 1, there are 3 different ways you can choose. 3 choose 2 is also 3, and 3 choose 3, that means you are given a 3 of them and you choose all of them. That means there is only one way to choose this. So what are these numbers? 1 3 3 1. Where do you see these numbers in a binomial expansion? So 1 comma 3 comma 3 comma 1, they are actually nothing but the coefficient of a plus b to the third power. So let's check it out. Where do you see them? 1 3 3 1. They are 1, 3, 3, 1. So what do we call them? They are called binomial coefficient. We call them binomial coefficient. All those coefficients of a plus b to the n, the expansion, those are nothing but the binomial coefficient. Now remember that previous section we talked about n choose r. We also write it as a this notation, and they are nothing but the binomial coefficient. Okay, so let's explore further. What is the difference between a plus b to the 4, a minus b to the 4? So you can say that a plus b to the 4 is bringing those answers. So that's if we can discuss. A plus b to the 4 is a to the 4th, 4a cube b, 6a square b square. You can see those coefficients are 4, 6, 1, 4, 6, 4, 1. And this, if I have a negative sign is nothing but actually you can write negative b to the 4. So b is negative. So anytime b is negative, you can notice that that's a negative sign and negative sign. So how are they similar? How are they different? Do we have to do more work if it is a negative? No. They both have a same number of terms. They both have a 5 terms. And the coefficients are also same 1, 4, 6, 4, 1. But then what is the difference is negative number to the odd power is negative. So that's why you have second and fourth terms are negative. That's the only difference. So anytime you have to have a positive and negative, you don't have to do the different things. You just consider that a plus negative b to the fourth. So let's explore further. What is a Pascal's triangle? If we eliminate the signs and powers of variables a and b in the previous array, we get binomial coefficient that is nothing but Pascal's triangle. So what is Pascal's triangle is nothing but the pattern. This is considered zero power. Anything to the zero power you get nothing but 1. 1 plus 1 is a power for a plus b to the 1. So this is coefficient of 1 and 1. This is the power 2, power 3, 4, 5. And the progression of this Pascal's triangle is 1 plus 1 is a 2. 2 plus 1 is a 3. 2 plus 1 is a 3. 3 plus 1 is a 4. You can see 4 plus 4, 6 is a 10. 6 plus 4 is a 10. 4 plus 1 is a 5. So you keep adding to make the next row. So for example, what will be my next row is a 1. 5 plus 1, 6. 10 plus 5, 15. 10 plus 10, 20. 10 plus 5, 15, and 5 plus 1 is a 6, and the last is a 1. So you can say this is a 0, 1, 2, 3, 4, 5, 6. This is the sixth power. You will have 7 terms, and this will be the coefficient of all those a's and b's. Now, what is a binomial theorem? Now, binomial theorem is not but the theorem, it's considered as a formula, and Pascal's triangle, you can expand up to certain number. What if you need to find 90th power or 25th power? Then you can't really make such a big triangle. And that's where this theorem comes handy. So theorem is a generic theorem which works for any power. So let's understand this theorem is a plus b to the n. These are the coefficient and choose 0. That is nothing but 1. And choose 1 is a n, and choose n is a 1, and b to the n, and all these are coefficients. Now coefficient has nothing but the combination, and choose 0 and choose 1, and you can see that the powers of a are going down and n minus 1 and onwards, powers of b going up and to b to the r, b to the 1. So it's the same pattern, that powers of a going down, powers of b going up, and this is the way you find the coefficient. So I would always recommend that you are supposed to know this generic term. This is called general term. And if you remember the general term, you can create the whole binomial theorem, and you don't have to like start everything, because many times the questions would be only asking for particular term. They would not ask you to expand everything. And if you are finding everything and then finding particular term, you are not being efficient. So good news is this binomial theorem is given in formula sheet, but I wouldn't count on formula sheet. I would just memorize this general term. And choose r, a to the n minus r, b to the r. So let's use this. Okay, so the question is find the coefficient of, let's understand the question. Find the coefficient of x to the 4 in the expansion of x plus 3 to the 5. Now, again, I would say that if you find all the 6 terms and then you find the x to the 4 and then you find the coefficient, you are not being efficient. You will run out of time. So, if I remember the general term, remember the general term is n choose r and a to the n minus r, b to the r. That will be general term. So, here, what is n? N is 5, a and b. So, let's set it up. N is a 5. I don't know what that number is. We will figure out. Then I have a x and I have a 3. And we are going to use the pattern. If I need coefficient of x to the 4, so the common sense tells you that this has to be 4. Then only you get x to the 4. Now sum of these two number is n. So this number has to be 1. Then only 4 plus 1 becomes 5. And then that means this is a 1. So check it out. That r always goes here. And that's it. This is what the x to the 4 term. Now comes what do we do? 5 choose 1. Some student says, do we have to use formula? Do we know 5 choose 1? There is only one way to choose uh, given a 5. There is only 5 possibilities we have. So which is 5 times 3 times x to the 4, and this will give you 15x to the 4. And I would say coefficient of x to the 4 is 15. You have to declare the answer as a separate. You can't just stop here. You have to declare the answer coefficient is. Now, if you don't remember 5 choose 1 is 5, don't worry. You can use the formula, which is 5 factorial. 5 minus 1 is a 4 factorial and 1 factorial. And 5 factorial over 4 factorial is nothing but the 5. So let's review quick factorials. 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. You can cancel all of them. Left is 5. Now I wouldn't count on calculator. I would say that this could be on a non-calculator side, and it is expected that you know what is 5 choose 1, which is 5. Okay, so let's take a look at another example. We have two terms, x to the 9 and y. Again, this is my a, this is a b, this is a n. So let's set it up. You must show the setup, which is n is a 4, x to the third, y. This is a, this is b. Okay, so now let's look at the pattern. You want x to the 9 and y to the 1. Here, this is a 1. Then only you get y to the 1. But then these two numbers add up to total 4. So then again, 3 plus 1 is 4. And 3 to the third will give me 9. So what should be this number, which is same as 1? So let's simplify. 4 factorial. I'm not going to take a shortcut. I'm going to explain what is 4 choose 1. 4 factorial, 1 factorial. 4 minus 1 is 3 factorial. X to the 9, y to the 1. And 4 factorial divide by 3 factorial. That means 4, 3, 2, 1, 3, 2, 1. Left is a 4 times x to the 9 and y to the 1. So my answer is 4 because it's asking for coefficient, which is a 4. Coefficient is a 4. Know the difference between coefficient and the term. Okay, so now let's take a look at a little bit more complicated problem, which is negative exponent. So first of all, let's make a connection. Coefficient of x to the third. Coefficient of x to the third n is 7. So I'm going to rewrite this is 2x minus 3x to the negative 1 to the 7. Now here, this is a little bit complicated because they both have a x. So this coefficient of x to the third is a simplified term, and then the coefficient has to be figured out. So let's set it up. 7, then you have a 2x, and you have 3x to the negative 1. Okay, so now they both have x term. So what would be these two numbers which I simplify, take a power of power and simplify, and I get a 3. So basically this is a 1, positive 1, this is a negative 1. And how do you make 7? So think about the combination. What numbers would give me add and subtract, or you can say subtract will give you 3, but you add will give you 7. So what numbers will, two numbers, pick two numbers, you add, you get 7, you subtract, the other combination will give you 5, 7. So I would say 5 plus 2 is a 7. And if I simplified x to the 5, x to the negative 2 will give you 3. That means this is a 2. And now this is simplifying. 7 choose 2, which means 7 factorial. 2 factorial, 7 minus 2 is 5 factorial, times 2 to the 5, x to the 5, know the exponent, 3 to the 2, x to the negative 2. You have to distribute. Let's figure out final answer. 7 factorial over 5 factorial is 7 times 6. 5 and 5 get divided out. 2 factorial is a 2 times 2 to the 5 is 32 times 3 to the second is a 9 times x to the fifth, x to the gives you x to the third. So final answer is coefficient of x to the third is 7 times 6 times 32 times 9 divided by 2. You could multiply out, and that number comes out 6048 x to the third, and answer is 6048. Yes, you could use a calculator to do this multiplication, but get ready to do one of these negative exponent as well. Okay, so now we have different types of problem. Here in this case, this says use binomial theorem or Pascal's triangle. So I'm going to show you, I need to see minimum 3 steps for this kind of problem. So expect that this is a 4, so that means you have a 5 terms. What are the 5 terms? And this is A, this is B, this is N. So let me show you one example what I'm expecting here. So write 5 terms, 2x, y square, 2x, y square, 2x. I highly recommend you show the parentheses because most likely you will miss the coefficient. So 1, 2, 3, 4, 2x, y square. Now comes coefficient. First is always 1, last is a 1. You can check the Pascal's triangle or binomial theorem. If this is pretty much pattern, so this is a 4th power, that means second is a fourth, and this is always a mirror image. So second to last is also 4. And the left is the middle one, which you can easily figure out that that number comes out 6. Okay, so this is the step you must show. Now the next step is simplifying. So this term, oh no, sorry, my bad, I forgot to write the powers. Powers of A is a 4, 3, 2, 1, 0. And powers of B is 4, 3, 2, 1, 0. Anytime you make a mistake, you can check 4 plus 0 is a 4, 3 plus 1, 4, 2 plus 2, 4, 1 plus 3. Now the next step is simplifying. And if you did not put the parentheses, you would make it mistake as 2 to the 4 is 16, x to the 4, 0 power give you 1, plus 2 to the third is 8, 8 times 4, 32, x to the third, y square. Next is 2 to the second is a 4, and 6 times 4, 24, x square, y to the 4. And 4 times 2, 8, x, y to the 6. 2 square, right? 6. And last is 0 power give you 1, y to the 8. So these are the expectations that you do the work and show this step. Now, if it is a negative, let me bring my answer. I just explaining. You can check that. I want you to practice yourself. Negative exponent means you have to keep the negative sign. You have to keep the negative sign here. Negative power 1, 5, 10, 10, 4. Highly recommend that you keep the parentheses and you simplify. Now, if it is a radical, you can write it as x to the half plus 3 to the half and 4. And I want you to practice simplifying and check the answer posted in the answer key. I'm going to stop here. Make sure you watch the second part of the video.